5, 3, 2, 1, 0, and liftoff of Space Shuttle Atlantis.
When we were young, most of us dreamed to be astronauts, to fly in space and witness the majesty of the universe. How about the part where you can float and experience zero gravity? I'm sure most of us got excited just by thinking of it. But do we know how the rocket space, the only transport to space, was tested? Here is how space rockets are tested before launch. By the way, make sure to click that subscribe button to stay up to date with all our engaging videos, and use that trigger finger by smashing that like button.
Booster ignition and liftoff of the Space Shuttle Discovery, returning to the space station payload.
Now let's get into it. Rockets are exposed to very high stresses, especially during launch. To prevent malfunctioning during operation, rocket components, and especially rocket engines, undergo extensive testing and inspection. For example, new or modified rocket engines require testing to ensure that no combustion instabilities will occur. When using a liquid propellant, the supply mechanism needs to be characterized and optimized. Measuring the dynamic ignition pressure is essential for a safe rocket launch. And of course, there are allocated facilities to do this. A rocket engine test facility is a location where rocket engines may be tested on the ground, under controlled conditions. A ground test program is generally required before the engine is certified for flight. Ground testing is very inexpensive in comparison to the cost of risking an entire mission or the lives of a flight crew. Because what would be compared to the value of life, right? The test conditions available are usually described as sea level ambient or altitude. Sea level testing is useful for evaluations of start characteristics for rockets launched from the ground. However, sea level testing does not provide a true simulation of the majority of the operating environment of the rocket. Better simulations are provided by altitude test facilities. What do sea level tests mean? In here, the facility must restrain the rocket and direct the rocket exhaust safely toward the open atmosphere. Structural integrity, system operations, and sea level thrust can be measured and verified. However, rockets are primarily intended for operations in very thin or no atmosphere. Systems that work well on the ground may behave very differently in space. A typical sea level test stand may be designed to restrain the rocket engine in either a horizontal or vertical position. Liquid rocket engines are usually fired in a vertical position because the propellant pump intakes are designed to draw fuel from the bottoms of the fuel tanks. The effects of the propellant weight on the thrust measurement system, TMS, must be accounted for as the engine is firing. The rocket exhaust is directed into a flame bucket or trench. The flame trench is designed to redirect the hot exhaust in a safe direction and is protected by a water deluge system that both cools the exhaust and also reduces the sound pressure level or loudness. The sound pressure level of large rocket engines has been measured at greater than 200 decibels, one of the loudest man-made sounds. Solid rocket engines may be fired in either a vertical or horizontal orientation. The thrust measurement system does not need to account for the changing weight of the rocket in a horizontal position. The associated flame trench need not be so sturdy as with a vertical test stand. However, a water system may be less effective at reducing the sound pressure level. On the other hand, the advantage of altitude testing is to obtain a better simulation of the rocket's operating environment. Air pressure decreases with increasing altitude. Effects of the low air pressure include higher rocket thrust and lower heat transfer. An altitude facility is much more complex than a sea level facility. The rocket is installed inside an enclosed chamber which is evacuated to a minimum pressure level before the rocket firing. A typical chamber operating pressure of 0.16 psia is established inside the chamber by some form of mechanical pumping. Mechanical pumping is typically provided by steam ejectors or diffusers. If the products of combustion from the rocket firing include flammable or explosive materials, the chamber must be inerted, typically with gaseous nitrogen, GN2. The inerting process prevents the buildup of potentially explosive materials inside the chamber or exhaust ducting. So that's how it is ensured that rocket space is safe for launching. What do you think about how space rockets are tested before launch? Let us know in the comment section below, and hey, if you've enjoyed the video, don't forget to like and subscribe to our channel so we continue giving you the best content. Thanks for watching. See you in the next video.